Hello everyone! Welcome to our webinar. So, I'm Maria from ENCY Software, and I'm here today instead of Andrei. I know that you have been waiting for Andrei, but he's assisting me today, and he's helping with the chat. Don't lose him. Before we start, and before we go to our really interesting topic with Swiss lathe programming, let me ask you to check the sound and give me the feedback if you can hear me well and if you can see me well. And while you're making your notes in the chat, also please put your region, where you're coming from. That's essential for us to know. Thank you. So while you are doing that, let me also make you some more minutes till everyone joins and share with you our agenda for today. So we will have 1 hour together approximately, and it will take 45 minutes of live demonstration and presentation and about 15 minutes of Q&A session. So as usual, you can put your questions, notes, any comments in the chat, and we will take care of them once I finish the demonstration. Okay? Couple of words about who we are. We are ENCY Software, an international engineering team located in Cyprus, and we are a fan of engineering. So it is reflected in our mission. We want to redefine the possibilities of cadcam for the better future. And what we do to meet our mission, we create the software and the cadcam workflow that results in the fastest in the industry transition from the design part to the finished part. Said that, that's essential to highlight that we are fighting for the time. And with Swiss lathe programming, it's even more important to know, because in any Swiss lathe machine, the producer is fighting for each second of the machining time. So today at the webinar, I will show you how we can reach the finished part in the shortest time thanks to ENCY tools and ENCY functionality for Swiss lathe programming. Before we go to the really ENCY software and real interface, let me introduce you our ecosystem of ENCY software solutions. With our main products, which is toolpath generation software, which is CAM software called ENCY for CNC programming. We also have ENCY for robot offline programming, which is ENCY Robot. Besides that, we have ENCY Tuner, the verification and G-code-based simulation software. And we have ENCY Clouds, the collaboration platform that helps to implement the software and to make the communication between you, your teammates, even faster inside ENCY environment. Okay, so we're gonna start with ENCY, which is cadcam software for CNC machine programming. And here I would remind you what we have in general in ENCY to have the workflow. In our software, we focus on interface and user experience. So interface is the first that any user meets in the software. That's why we want it to become crisp and crystal and simple as much as possible. We introduce dark mode, quite elegantly looking, to reduce eye strain. And we support 4K display, and we also have smart hints. I will show you the interface of ENCY for sure today, and all of these nice features you will be possible to look at. What else we have in ENCY to make the workflow for cadcam programming? This is the platform that incorporates CNC machines and robots, so we have one engine to program both worlds. We have machine-aware technology, and we will look at that pretty much today because it's essential for Swiss lathe programming. We also have digital twin and cloud-based applications, and all of that is developed by technologically independent team, so we don't use any third-party solutions. Everything that we deliver to our users is developed by ourselves. That's why it's important for you to know that all of the changes in the software are done pretty fast, thanks to the principle that we deliver technologically independent products. Okay, so machine-aware technology, I stop only at this point here because in Swiss-based programming, it's pretty critical to know how the machine setup works. And in ENCY, the machine-aware technology means that we make the toolpath and the simulation based on access limitations and capabilities of the equipment. In the many other CAMs, in traditional CAM workflow, we will be aware of any collisions or gouges at the pre-delayed step, so after the toolpath is calculated and once the simulation is done. In ENCY software, we change that and we make the background simulation at the very beginning when we calculate the toolpath to avoid collisions and to provide the information to the user and make the workflow even faster. So we want to avoid the errors before we go to simulation and post-processor and G-code simulation. With these features and capabilities, in ENCY we can support any milling machine, so 3x or 4x or 5x machine we can program in ENCY. We also support additive or hybrid machining technologies when we combine subtractive and additive. And what we're gonna look today is the mill turn capabilities and multi-channel machines. For sure, we can program all of them in ENCY interface. If you have already ENCY installed, all of the things, all of the features that we will look today with you are implemented in the latest version, so don't forget to update your software till this version. And the software will inform you if the update is needed. Okay, so we're gonna start. Let's look at Swiss type machining that is really enhanced with automatic channel synchronization. For many Swiss lathe machines that we have studied and elaborated, the machine kinematics looks pretty similar. So in the typical Swiss lathe, we will have a main spindle, we will have sub spindle, we will have a main gang with X and Y, we will have a second gang, could be that we will have some swivel B axis, and this kinematics and this machine setup is pretty typical. You can say, yeah, it is. And how we can program all of these axes, all of these gangs, spindles, how we can really make the programming of these machines fast and efficient. And we also ask this question to ourselves, and we ask what challenges a Swiss lathe programmer has in front of him. For sure, it's quite complex machine kinematics, so it could be 10 or even more programming axes. That's quite challenging workflow because besides the cutting operations or cutting strategies, we need to be aware of additional operations for Swiss lathe like pickups or sub-spindle working. And we need to have parallel machining in our mind. So we need to be aware how each of the channels work together. That's not an easy task. And in ENCY software, we want to help the Swiss lathe programmer with our tools, and I will show you today how we can program this kind of machines in ENCY pretty fast. So we're gonna start with digital machine setup. What it means? Let me show you. So we have ENCY. This is the interface, dark mode. And this is one of the typical Swiss lathe machines that has already the axis. So this is main spindle with Z1. This is the main gang with X and Y, and there is also C axis. And this machine schema, this machine kinematics, really helps to understand how the Swiss lathe programming can look like. So the machine setup or machine schema is needed for sure for simulation, and also to synchronize the channels, and also to understand how the real machine can work. In ENCY, we have machine control panel that works not only in the simulation mode. You see, I don't have any operations right now, but I can use it to understand where is axis limits, where I can really reach the part, or where I can do not reach the part. So it's one of the tools that helps the programmer to deal with complicated machine setups. Additionally, in machine setup, we also have important settings that we will touch with you later on. And one of them is reordering mode that helps to redefine the multi-channel programming. So first of all, what we need for any Swiss project, it's machine schema. Okay. And have this setup already done, we need to program, again, besides cutting operations, we need to program multi-channel synchronizations. We need to program bar feeding, because Swiss lathe programming is almost impossible without bar feeding. We need to take care of subspindle, of turn takeover operations, and we also need to program cutoff and part catchers. So you can see that that's one of the challenges that I mentioned at the beginning, which is not so easy to manage for the Swiss lathe programmer. And in ENCY, we help to do that with pretty simple project structure that's transparent. We create part 1 and part 2, and we can easily understand where the part in which status is located in each moment. For bar feeding operation, we need to set up only one parameter that is graphically designed, and you can check it how it works. For cutoff operation, we don't need almost anything. We need just to define from which side to cut the operation, and the system detects, makes all the rest for us. Okay, and for part takeover, we have already defined the pickup position, and the system makes the takeover operation almost automatically. So let's give a look how we can program a Swiss part in ENCY. Have this functionality in mind. Okay, here is the project. Let me show you what we're gonna machine. This is the part. Okay, and what we need to do to make the machining. First of all, we need to define part 1 and part 2. We have a special tab in the operation list with to create these parts. And it's important only to define in which spindle each part is located, and which coordinate system is assigned. That's pretty fast. So for part 1, we use main spindle. For part 2, we use counter spindle. And actually, this is the graphically highlighted parameter that we need to set up. This is the pickup point. Okay, could be -15. That's it. The structure is ready. Okay, let's start with the bar feeding operation. In most of Swiss lathe programming workflows, it has to be the first one. And these operations that are not cutting but also important are accumulated in Move Part tab in the ENCY interface. So we pick bar feeding, we go to second tab and we find this important parameter, bar overhang. You can see it in the graphic area. By the way, we can switch on and off the machine visibility, and we can also switch the, excuse me, we can switch any of the machine components whenever we need, or we can make them transparent. That's really easy to manage. So now I show you the bar overhang, which is automatically calculated as a part length plus some additional millimeters to cut the part. We can make it a little bit more for our part. Then we will see how it works. So we create the operation and generate the toolpath. Let's take some more operations to understand what we're going to do. So we're going to make the turning operation. You can see. And in ENCY, actually, the system detects the side of the part where we want to machine, highlights in the job assignment the profile, and our task here is only to adjust it a little bit to our needs. So with arrows in the graphic area, we can define where we're gonna make the lead in and lead out. Okay, let me pick it. No, done. Okay, so we make the profile that we want to machine. We adjust lead ins, lead outs in the graphic area, and we calculate the toolpath. Okay, so what we're gonna do next? Okay, let's make the simulation. In the simulation tab, we go to single channel, just in case. And this is the workflow that we're gonna make. So the bar fitting, then cutting with stock removal. Okay, that's it. So what we do next with this part? We can make cutoff operation and the pickup. These operations are pretty typical. So in lathe tab, we have all cutting operations for lathe machines, and we have lathe part off. As any cutting operation, it has job assignment tab, which automatically picks the profile. In this case, I don't need to cut from right side, but I need to cut from left side. So we reverse the toolpath, and we can apply the toolpath. That's it. We can also make some small adjustments just for more convenience. We can delete chips. And let's go to the turn takeover operation, which is important because it has to be integrated or coordinated with a lathe cutoff operation. So in the same move part tab, we have turn takeover. And in this operation, we have a couple of settings that are essential to explain. The spindle position. This is the point which we program inside the machine. And basically, it's set up inside the machine schema. So we don't change it here. And if you need to change it, better to do it in the machine definition. So what we do need to program here is the peak feed distance. At this point, we switch from fast feed rate to feed rate before the pickup point. So this is just the movement where our sub spindle changed the feed rate. Okay, all the rest we leave as it is. So we just okay, we need to calculate lathe cutoff, because otherwise the turn takeover would not work. So we make it all the operations calculated. We go to simulation, and what we're gonna simulate, the full workflow. Again, start from the beginning, make some machining here. Okay. Okay, so it's really simple, right, to make it. And let's do one more operation that will be the last one for this part, I hope. It is machining at the second part after the takeover operation. And we use the same operation for deroughing. Okay, so the system detected something that's we need to take into account. And what is essential here, that if we use this operation, the toolpath that is highlighted will look like that. That's not what we wanted, because we have already defined the tool for this operation like this. So we choose it in the tool manager. And again, we need to define the profile, what we're gonna machine. So in this case, the profile is indicated inside the part. It's not what we needed, right? For this, we need to change machine on the axis. So we will program the machining in the negative area. Swiss type place, the Ducan machine in negative X area. And we're gonna do the same. We're gonna cut a little bit the profile and make it a little bit simpler. So lead ins and lead outs. Looks nice. Let's calculate the toolpath. Okay, so there are some collisions, and we will check what is there. You see that in the workflow before the simulation, we can see the red node. It means that there is something not so well defined. Okay, so there is the gouge in the part, and the tool is detected as gouging. Let me simulate and define where exactly the gouging happens. In the simulation, we can start from the beginning, or we can start from any point which we like to start with. And we're gonna make the cutoff, take over, and then the additional operation after the pickup. Okay, so this is not the perfect movement that we had. Let me try to fix it. Okay. Okay, hope that it's okay, but here we have really the problem. So the system detected the problem at the approach. Could be that it's something happened from this. And we need to switch it on also to wait. Second, please, let's change back. Okay. So this is the problem. The real problem is in the direction. Great. So fixed. Hopefully. Let's double check in the simulation. Okay, so we're gonna move the part, and let me show you the last operation. So why we're doing all of this is because besides the really cutting operations in ENCY, we need to program also the additional operations like cutoff, turn takeover. And now we have done the simple steps in the consecutive mode. It means that we did step by step all the machining operations, and in the simulation we also have seen the machining without real multi-channel mode. And this is the point where we can switch to the synchronized mode. The one benefit of Swiss lathe is really to make the operations simultaneously, and this workflow is managed in ENCY engine automatically. We do not apply any changes in the operations itself. We just change the mode and switch to multi-channel with SilkLines. And you have seen how the structure has changed. Let me show you with a little bit, here, with bigger sizing in the text, what have happened. So we had simple consecutive workflow that has been transferred to multi-channel synchronized workflow. And we did it with only one click. We did not apply any additional changes. And it's done in ENCY thanks to the internal algorithms, internal technology that knows precisely the machine kinematics, which axes are involved in each of the operations and what can be synchronized. So from the consecutive process that could be defined like that, from bar feeding to main spindle machining, then could be some machining in both spindles, then cut off and second part of the machining, we have transferred or converted that one to the real parallel programming. And you remember one of the challenges that is in front of the Swiss lathe programmer is to have in mind that the machine really can work in parallel. And so these two parallel channels, so channel 1 and channel 2, we combine them with automatic sync lines and weight codes inside ENCY, and we highlight how the machine will work in this synchronized mode automatically in the simulation. So this diagram, or the block schema, helps to understand what we do in our ENCY internal, I would say, engine to simplify the parallel programming. Okay, so this is the typical thing that we're gonna use in this in Swiss lathe programming and in general in multi-channel programming. Just for those of you who have seen the SilkLines term for the first time in ENCY, let me explain what it means. So in Swiss lathe programming, in multi-channel programming, we need to make the synchronization markers that would mean for the channel 1 to be paused till the synchronized operation in channel 2 is completed. And these markers or these lines generate weight codes, and they're essential to be present in the CAM software. Why do we need them? Because then the real machine, the real Swiss lathe machine, will use these weight codes in the ENCY code and will apply them to run. So let me show you what we see in the CAM software relative to synchronizations and weight codes. We are at this project. We have programmed pure turning operations, and we can also add here some milling or drilling operations. That could be interesting to see what we're gonna make with the drilling. And I guess we can open the project that is already programmed to save a little bit our time. Let me open. Okay, it's coming. It's the same part. Yeah, so we have just added some drillings at main spindle, also chamfering and taping, and same operations on the opposite side. So this workflow engages the tools installed or mounted at one gang and they are controlled by one channel, but we need to make them synchronized in a second channel. In this workflow, if we make it in the single channel mode, you see they are, let me do like that. Okay. They are done without any issues, and they're done consecutively. And once we switch to this mode, we receive the weight codes and the links inside each of the drilling operations. Let's go and look how it will be machined with this workflow. So you see, both spindles are making some turning, roughing operations. Okay, we're gonna speed a little bit. And at this point, we can see that tools mounted at one gang are synchronized. It's really nice to have these operations automatically synchronized. We did not do anything special, we just switched on the multi-channel mode. So this engine, or with this technology, simplifies the job for Swiss lathe programmer. And it's not all that we can use for multi-channel synchronization, because with this nice structure, with these foreign links, we really can make some changes. For example, if some of the tools or some of the operations are not needed. And imagine if you need to delete something, what will happen? Let's try. Okay, let's pick this operation. We can delete it. And then we need to recalculate the structure, the workflow. And again, we go to multi-channel mode and we look at our structure. Nothing changes. The only changes that we can find is the operation, the missing one, has been replaced with the weight tool code. It's not a cutting operation, it's kind of an empty tool path operation, but it's really needed to be there, because in this case we don't ruin the structure and we can make all the rest of the machining without any time conflicts. So let's start from the beginning and give a look what will happen at this point when we have deleted the chamfering and replaced with the weight tool code. Okay, so you have seen that the part has been programmed. All the drillings has been done, besides one that we have deleted. Again, we don't need to make any changes in the operations in case we need to adjust something. And one more important note that is needed to highlight is to detect that in multi-channel mode, in synchronization mode, we have lots of links, we have lots of coding, and this is CL code that later we will transform to the ENCY code for your Swiss lathe. And this CL code is practically the same as we will need in the machine. So in the postprocessor, we don't need to apply a lot of changes. We don't need to make some special logic to work with weight links or analyze what operations has been before. So we just translate this CL code to the ENCY code, and it simplifies a lot the job for postprocessor developers. Really, it becomes only the translator. So with the structure that we have seen with you, we have deleted the one of the operations. I guess that after the webinar, all of the projects we have seen with you together will be uploaded to the project library, and you will be capable to play with these projects directly and try this workflow, try these tools that we have prepared for you in ENCY. Okay, so the automatic links, structure of the operation, the sync lines is important for switch lathe and multi-channel programming. And how we began, the challenging point for this programming is the parallel workflow. And we manage this and we handle this automatically in ENCY. Okay, what else we can find? We have seen synchronized drilling already. One more nice and hopefully important for you type of the machining would be a long part machining. And as you know, in switch lathe machines, the axis limits and the way how long the Z1 and Z2 can travel is really limited. So the really long parts cannot be machined in one setup, and we need to make small portions, then rechecking, then again small portion. So this specific workflow can be managed in ENCY with additional operation that we will look at right now. So it's called subspindle working. Okay, some warnings, could be some notifications. Okay, and this is again quite simple part which we can program in ENCY. The important here would be to make the multi-step rechecking in machining strategy, so that we can meet the tolerance of the part, and we can don't make any collisions, and at the same time use the axis limits efficiently. So what we're gonna do, we're gonna pick the part. We have a little bit different machine. It's Hanwha, one of the most popular maybe, and we also have prepared the structure. So it's part 1 and part 2. And again, part 2 is something that we have defined in a subspindle, and we define the checking position, and that's it. Let's start with the same workflow as before. We create bar fitting with a bar overhang, and in this case I guess that 100 is pretty much, that's not that we want, and let's make it 70, so then we will see if it's enough or not. And let's start with some machinings. Again, some OD roughing. The tool is already defined. We have the profile that is automatically highlighted on the screen. Okay, let's cut a little bit. Let's make it till this point. Could be here. Done. Okay, so this is the tool path number 1. We calculate both operations, and let's make the support. So let's make the subspindle working right now once the first portion of OD roughing is done. So we add this operation from move part tab. Done. Let me switch back the machine to explain better the parameters. And in my opinion, it's one of the most important operations for switch lathe, because first of all, it controls 2 spindles, because the part is still checked in spindle 1, and we will engage the spindle 2. So in spindle position, we still use the default value, which is 0. It comes from the machine setup. And what we're going to change is the pickup position. And if I move the scroll on my mouse, you can see that subspindle is moving. Let's make it like 15. And peak feed rate distance, it's again the distance where the feed rate will be started instead of fast movement. Okay. Couple of more settings that are essential here. Move part. Here we switch it on because we want the sub-spindle picks the part, make some movements with the part to give us another portion of the machining. So we enable the parameter, the 70 millimeters, we can keep it as a default value, and with engage Swiss type place. So it's one of the default settings that we need for this operation. Okay, we calculate, and let's go to simulation and let's give a look what we're gonna get. Okay, so let me check timing. Okay, great. So we had bar fitting, we had OD roughing, and soon we will have the sub-spindle. Okay. Okay, so we're gonna check the part, and then once done, we will make additional operations. So don't be afraid that the sub-spindle has gone. No, it will stay. Okay, we add the roughing after the support. No, it's in the wrong area. We delete it. We go here. We create it here, and you see that the indication shows us that there is something. If we program it this way, there would be a collision on the machine. So we know precisely what we can make and what we should avoid and Swiss lathe programming, thanks to our machine axis limits. Okay, another toolpath. Okay, and let's switch it off. Let's make also the grooving. One more. So for grooving, we have various strategies, the same workflow as for any lathe operation. We have a profile, then we limit the profile in the area where we really want to machine, and could be essential to change the cycle. Should be, I guess, grooving. Let's try. Okay, so there should be some collisions. We will double check. And the next one will be another rechecking. So let's put it also at the end of this sequence. And again, we keep the spindle position 0, but we change the peak position. Oops, sorry. I'm gonna make it, let's stay there. Then we also move the part, and in this case we need to move the part even more. So we need to have more raw material visible, because otherwise we won't be capable to machine anything. Okay, let's do like that, and Swiss type lathe. So what's here? What is going on? What is the axis travel limits? Okay, we will see. And what is here? Okay, axis travel limits. It could be because we did not recheck the part enough from the previous operation, but let's give a look. Our simulation always helps us with that, because at the settings of the collision detections, we can always enable arrow and collisions and gouges, and also machine collisions, hold the collisions, and split or merge them together. Let's do that. Let's make the simulation. Okay, it was bar fitting. Okay, I did not reset the, the workpiece status before we start, so that you can see the stock removal. Okay, so Okay, one recheck, and you see the collision happens because we did not leave enough space here. We're gonna fix it. We're gonna fix it with a bit of adjustments here. So let's make it less, and let's recalculate the path. Okay, let's go to simulation, and again, let's make a couple of steps. Okay, so it happens because I guess we did not recheck the part at the bar fitting enough, and this is again the way to know how your real machine can work, because it's something that we need to be aware of at the very beginning. So the bar fitting that we used at this point at 17 could be not enough because we needed more parts to be done. So we can increase, and we can recalculate. We can check again. I guess we will not finish this part till the end, but the real task for this part would be to be machined in separate steps. And let's give a look how it will be at the end point. So we need, no, we don't need to change it. This one. So when we're gonna program this kind of parts, we need to know the precise axis limits, and we need to know precisely how much we're gonna pick the part from each of the rechecking steps. So we can program as much as needed, and at the end of this rechecking we can do the cutoff and the takeover, and then we can make some additional machining after after we finished. So let's give a look and switch the synchronization mode, that again is done automatically. And in this case, no, it's too much. So we're gonna see how the automatic links have coordinated each of the movement in channel 1 and in channel 2, thanks to the precise weight codes. Let me know. Oh, I cannot open. 1 second. Okay, so before we go to one of the next steps, which is the postprocessor, we will not look at the coding today, don't worry. We will have a bit of more slides about postprocessors. So again, this is the CL file that we need to convert to the ENCY language of our real machine, and being already enough for the postprocessor, we really want to make the next steps of the postprocessor developers pretty simple. So in the postprocessor, for sure, we will need to be aware of the M codes or special cycles of your precise machine, but it will not add any logic in the workflow. It will only convert the existing routines, the existing SilkLines to the language of your particular machine. In ENCY installation kit, we have some postprocessor for Swiss lathe machines. You can find them if you install your ENCY version, and they're available here in this format. Let's pick it and let's run the G-code simulation, and you see that in the output files we have already 2 files generated, so one for channel 1 and another for channel 2, and this language becomes almost the same as we have seen in the CL file. For sure, you can test it once you have your ENCY version, or you can play with our machine setups defined in the delivered in the installation kit and in the project library. With pretty interesting stuff, which is ENCY license options. What we need to have in ENCY license to be capable to program Swiss lathe. It's interesting because it depends mostly not on the machine, but on the part that you're going to machine. The first one that we have seen with you today is really a simple part. And in ENCY license configuration, you will need only the basic milling license plus option for tuning and multi-channel synchronization. This is the license for simple parts. If you're gonna have a little bit more complicated parts where you need more milling functionality with maybe some contouring or some scallops, so you will need 3-axis milling advanced configuration with the same options, the tuning and multi-channel. And if you have really advanced sweet lathe machine with B-axis, or you're gonna make some medical or dental parts where they really make complicated shapes, you can use 5-axis milling configuration in ENCY with the same tuning and multi-channel mode embedded. So we have a flexibility in license configurations, and the precise license configuration you can request at your original partner, or you can use get a quote tab and ENCYcam.com, and your request will be elaborated pretty soon. So let me remind you that we have online training materials available on our YouTube channel. We have already plenty of videos for CNC programming and for robot programming, so 2 tracks are available for you. If you still have no ENCY installed and if you want to try, so go to ENCYcam.com, get your trial, and play with the software with our dark mode, with our example files that installed together with each version of ENCY, and it will be full functional license for 30 days. Before we finish and move to our chat and to your questions, let me announce 2 more events before end of the year. So next Thursday, we will continue with mill turn functionality in ENCY with really complicated and interesting topic. So we will see how to program mill turn machines with B-axis. And at the very end, at December 23 at noon, we will have ENCY cadcam holiday quiz. So don't miss the events. Go to encycam.com at news tab and register to all our upcoming events. Hope to meet you there, and let me move to our chats and give a look at your questions. Second, please. I will try to read only English comments because in some cases you use your native language. I'm sorry, but we do not speak other languages. So we can reply to the first one. I need to work with custom shaped turning tools. How to define them? Okay, so custom tools, they are supported in Tool Manager, but I had no time right now to make it visible for you. So definitely you can address your question either to your dealer or to our support, and we will show you how to use this. Another question was, isn't having the turn takeover operation after the cutoff operation really the part fallen off? Yeah, you're right. It was one of the things that was not so well explained, but it was because we did not switch the multi-channel mode at that point. But once you did it, the cutoff operation will be really supported with the subspindle. I can share the files, or as I said, you can find them in the project library and check it at your end. Another question is, the product looks great. Thank you. We noticed some features that are not present in the other products. Thank you. We do our best. So, drag and drop functions for the start and the stop macros. Great, thank you. We hope you will appreciate that in your version of ENCY. One more, how to show the G-code based simulation with multi-channel on. Good question, thank you. currently in ENCY Tuner, we do not support the multi-channel synchronizations and this kind of projects. But again, being technologically independent, having the really nice team, we can do that fast. If we do understand that it's needed, we will apply in the next versions, I guess. Okay, so can we add manual waiting things between the operations? Yeah, for sure. That's available for you because there is a tab with delete things, add things. You can play with them. You can reposition the existing links, no problem at all. Just switch the multi-channel mode and you will see these 5 or 4 buttons available for you. So you can do whatever you want with the synchronization links, but you need to be aware that once you do any changes, you become responsible for this synchronization. That's why we do a lot to automate this process and avoid any time conflicts. Okay. So also want to do with robots is impressive. Okay. Can we modify or customize how the synchronization process works? For example, can we change where the wait code happened? Yes, so replied already. You can do. Install ENCY and try yourself. I wasn't there from the beginning. Okay, so I might have missed it. Which Swiss turning machines are supporting and how many axes do they have? Actually, we are not assigned to any brand, so we can make the machine schema or machine definition for any brand. We just need the solids for each part of the machine. And we support two-channel machines with XZC at one channel and the same number of axes at the second channel. Also, we can support B-axis swivel heads at Swiss lathe, so it could be about 10 axes, right? If you have your machine definition and you want to check if we can program that, again, go to support, make a small comment that I want to check it, and our application engineers will give you the reply. Okay, so I'll work with Esprit and Esprit Age UK. Can I have a job, please? Okay, it's not the topic of the webinar, but definitely you can use the form contact us at the encycam.com. Okay, so do we typically keep part 2 origin point G55 on the inside on the subspindle? Usually I move it on the opposite face outside of the sub. No problem, no problem. You can do that in structure step when we defined the part 1 and part 2. I guess that in many cases, the Swiss lathe programmers prefer to keep them in the same point, but you can really redefine the coordinate system at the beginning, and the toolpath will be assigned to another point. No problem. Okay, thank you for the great presentation. I know how complex and challenging the topic of the Swiss lathe turn is. Great, thank you. So I hope we will meet again at the next webinars. We're gonna cover more complicated topics at 2025. So follow us in social media, follow our news and announcements. So I think that we can almost finish in case you still have some interesting questions. I like the question about purchasing, you know, and the last one I will read for today will be, I need to buy ENCY for 2 robot synchronization with multi-channels Fanuc robots. So I need proper training for this. Is there any option? For sure, we can use ENCY robot with synchronizations. We have this option available in the licenses, and definitely you need to contact us, and I will pretty sure that one of our partners will provide you the training. No problem. And install ENCY, play with our projects, give us your feedback, and hope to see you and to hear you soon. Okay, thank you.